Hey guys, welcome back to the channel. It's your boy here, and today we're uncovering something that's straight up wild. A massive, mysterious anomaly lurking deep beneath the East Coast that's got scientists buzzing like never before. What if a massive, slow-moving geological force is stirring beneath your feet on the East Coast? Scientists have just uncovered a colossal anomaly deep within the Earth, hinting at a potential mantle plume. Could this unseen powerhouse reshape the future of the region, or are its implications far more dramatic than we imagine? We're talking a hot blob of rock that's bigger than you can picture, moving like a stealthy beast underground. This isn't some conspiracy theory. It's cutting-edge science from 2025 that'll blow your mind. If you're on the East Coast or just love epic Earth mysteries, smash that like button now, subscribe for more insane reveals, and let's dive into this geological thriller. By the end, you'll be geeking out over what's under your backyard. Let's beast this anomaly. All right, team, let's start with the enigmatic anomaly. What lies beneath? The recent buzz kicked off big time in July 2025 when geologists dropped a bombshell study revealing a vast, low-velocity zone deep under the Appalachian Mountains, specifically the Northern Appalachian Anomaly, or NAA for short. This thing is no small fry. It's a gigantic hot blob of rock about 220 miles across, sitting 125 miles below the surface in the upper mantle. We're talking temperatures way hotter than the surrounding mantle, making it denser and able to drip like some underground lava lamp on steroids. Seismic data from advanced tomography, that's like an MRI for the Earth, painted this picture, showing slower seismic waves zipping through this zone because it's all melty and hot. Imagine sending sound waves deep into the planet and seeing this massive shadow pop up. That's how they spotted it. Recent models from the U.S. Array Seismic Network have imaged low-velocity anomalies stretching through the Mantle transition zone under the northeastern U.S., from New England down to the central Appalachians. It's not just one spot. There are thinned zones in the Mantle transition layer that's between 250 and 410 miles deep, hinting at thermal anomalies up to 100 degrees Kelvin hotter than normal. Epic, right? This discovery is shaking up everything we thought about the East Coast, which is supposed to be a passive margin, no wild plate tectonics like out west. The initial shock waves? Oh man, geologists are scratching their heads because this flips the script on established models. For years, we figured the Appalachians, these ancient mountains formed over 400 million years ago from continent collisions, were just eroding away quietly. But nope. This anomaly is why they're still standing tall, defying erosion that should have flattened them by now. It's like the mountains have a secret booster pack underground. Traditional plate tectonics says the East Coast is chill, no subduction or rifting drama since the Atlantic opened up. But now, this hot blob suggests leftover heat from ancient events is still at play, maybe even mimicking a mantle plume. Mantle plumes are those super hot upwellings from deep in the earth, like the one under Hawaii that spits out volcanoes. Is this one? Not exactly a classic plume rising from the core mantle boundary, but it's a thermal upwelling, a ghost plume, or remnant blob that's got similar vibes. Scientists are rethinking how continent breakups leave behind these hot surprises, and it's got implications for volcanoes, earthquakes, and even ice sheets if you look at its Greenland twin. No wonder the geology community is hyped. This could rewrite textbooks on passive margins worldwide. Setting the stage, let's introduce the key players in this geological mystery. First up, seismic waves. These are the heroes. Earthquakes send out P waves, fast, compressional, and S waves, slower, shear, that bounce through the planet. When they hit a low-velocity zone like the NAA, they slow down because hot, partially molten rock doesn't transmit vibes as quick as cooler, solid stuff. Receiver functions from stations across the U.S., think thousands of seismometers listening in, convert these waves into images, revealing thinned mantle transition zones under the Appalachians. Next, The mantle. That's the gooey layer between the crust, where we live, and the outer core, making up 84% of Earth's volume. It's mostly solid, but flows like putty over eons, driven by heat from radioactive decay and the planet's formation. The upper mantle, where our blob chills, is key for tectonics. And the crust? That's the thin skin on top, 3 to 44 miles thick, getting warped by what's below. Together, these players create the drama. The blob's heat weakens the dense root under the continent, making it buoyant and lifting the surface. It's like injecting air into a balloon. The Appalachians puff up. Now, let's unpack the origin story. This is where it gets beast-level epic. About 80 million years ago, during the Cretaceous period, Greenland and North America were splitting apart as the Atlantic Ocean widened. Think Pangea breakup on steroids. Tectonic plates rifted, creating gaps in the crust that hot mantle material rushed in to fill. This upwelling formed the N8A blob, denser and hotter than its surroundings, and it started dripping southwest due to mantle waves, chain reactions from steep temperature gradients. A twin blob under Greenland is doing the same, influencing ice sheet melt and flow. Fast forward to today. The N8A is under New Hampshire and New England, cruising at 12 miles per million years toward New York City. It'll hit the Big Apple in 10-15 million years. No rush, but imagine the long game. This isn't unique. Similar blobs form in continent splits, like under eastern Oman as a ghost plume. But for the East Coast, it's a remnant of ancient drama still shaping the land. Is this a mantle plume? Let's hype the debate. Classic plumes rise from the core mantle boundary, like Yellowstones, creating hotspot volcanoes as plates move over them. The NAAA isn't that deep. It's upper mantle. But low-velocity anomalies extend through the transition zone, suggesting upwellings that could link to deeper sources. Some call it a plume-like feature or mantle wave, tied to hotspots like the Great Meteor Track, which left volcanic seamounts off the East Coast. Bermuda's hotspot might connect too, with igneous rocks hinting at past plumes. It's not erupting lava now, but its heat could spark rare volcanism, maybe even diamond-bearing kimberlites like in ancient times. The East Coast isn't volcanic like Hawaii, but this anomaly challenges that. Could we see subtle quakes or uplift spikes? Now, the implications for the region. This is where it hits home, literally. For the Pacific Northwest vibes? Nah, but the East Coast could feel long-term changes. The blobs buoying up the Appalachians, countering 20 million years of erosion. Without it, they'd be hills by now. As it moves, New England might sink a bit, while New York gets a lift in eons. Seismic risks? The area has intraplate quakes, like the 1886 Charleston shaker, and this hotspot might weaken the crust, making rare jolts more likely. Climate tie-in. Like its Greenland sibling accelerating ice melt, this could subtly affect sea levels or groundwater if heat migrates. Big picture? It shows Earth's interior is dynamic, even on quiet coasts, influencing everything from landscapes to resources. Preparation, beef up seismic monitoring. The USA array's already on it. No doomsday, but knowledge is power. Whew! That was a deep dive. We've unpacked the NAIOA from its seismic reveal to its plume-like secrets and East Coast shakeups. Earth's full of hidden beasts, and this one's a slow-burn thriller. If this hyped you, smash like, subscribe, and comment. What's the craziest underground mystery you've heard? Let's hit 10 million views and geek out on geology, because the planet's the ultimate beast. Peace out.